Welcome you all. I am Sindhu from Mechatronics Engineering. Now we are going to see about LVDT. LVDT stands for Linear Variable Differential Transducer. It have another name, Linear Variable Differential Transformer, because we are using transformer 2 and it works under mutual inductance principle. The transducer converts one form of energy to the another form of energy. In LVDT, it converts linear motion, that is displacement, into an electrical signal. It is very accurate inductive transducer as compared to the other type of transducer. It works under mutual inductance and the displacement, which is a non-electrical energy, and converted into electrical signal. Now we are going to see about the construction. It consists of primary winding and two secondary winding. The secondary windings have equal number of turns. Primary winding is placed between either side of a secondary winding. A core is used to transfer the electromagnetic field from primary winding to the secondary source. We are namely primary winding namely as P and secondary winding namely as S1 and S2. A core is placed inside a former and the displacement to be measured is connected to the iron core. It has generally a high permeability and high sensitivity characteristics. Now we will see about the operation and working. Primary winding is connected to the AC source so that alternating current and voltages are produced in the secondary of the LVDT. The output in the secondary is namely E1 and the secondary coil S2 is namely E2. So we will calculate the output. Differential output will be E1 minus E2. Now the operation of a working operation of a LVDT, it comes under three cases based on the placement of a core. Case 1, when the core is in normal position, that means the core is placed between primary winding as well as secondary winding. So equal voltages induced in two secondary windings. So the output voltage is in null condition. The case 2, when the core is moved to the left of the null position. So in this case, the flux linking with secondary coil S1 is more compared to the S2. Due to S1, it will produce E1 value will be more than that of E2. So E out is in positive value. In third case, when the core is moved in the right of the null position, in this case E2 will be more comparatively to E1. Due to this E output, that means output voltage will be in negative. That means it shows the output to downwards of the reference point. This is the output characteristics of a LVDT. So in null position, the output value will be in 0. In the AC, in 50%, the output will be in a straight line position. In the 100%, that means a full range of core displacement, it is a phase shift. The advantages of an LVDT are it have a high range, no frictional losses, high input and high sensitivity, it have low hysteresis and it consumes low power, and also it converts electrical signal directly. First one is high range. Range means the difference between the lowest and the highest value. In LVDT, it have very high range of measurement of displacement and it can be measured under the range from 1.25 mm to 250 mm. Second one is no frictional losses as the core moves inside a hollow cylinder so that there will be a no loss of displacement and input as a frictional loss. So it makes LVDT more accurate device and it have high input and high sensitivity. So sensitivity means the quality or a condition of being sensitive. The output of LVDT is so high that it doesn't need any amplification and the sensitivity range will be about 40 volt per mm and it have a low hysteresis too. Hysteresis means lagging of magnetization. LVDT have a low hysteresis and hence repeatability is excellent under all environmental conditions. And it have low power consumption too. The power of about 1 watt is used in LVDT. It is very low power consumption compared to the other transducer. So the Direct conversion of an electrical signals, it converts the linear displacement to electrical voltage, which are very easy in process. The disadvantages or limitations of LVDT are it has affected under environmental condition. It have vibration. Applications of LVDTs are it is used in power turbines, hydraulics, aircraft, servo mechanism, factory automation, general industrial applications, process control, etc. Thank you.